This lesson is calculating and classifying angles using the 3D nets. We have laid out in the book here a pentagonal pyramid, and this is a 3D net, which is a 2D representation of a three-dimensional shape. You can see that the base of this pyramid is a pentagon. That's why it's called a pentagonal pyramid. And then each of the sides that come together at the top vertex are triangles, thus the pyramid. So what we're going to do is we're going to first calculate the measure of the angles T, S, R, V, and U. And since this is a regular pentagon, we are going to calculate all of the angles as being equal. So the formula for this is n minus 2 times 180 degrees. So n is the number of sides. We have 5 in a pentagon, minus 2 times 180 degrees. So the total is 3 times 180 degrees, which is 540 degrees. So we know that the sum of all the angles in a pentagon are 540 degrees, and since there are 5 angles, we divide each angle is equal to 540 divided by 5, which is 108 degrees. So now we know that angle R, V, U, T, and S are 108 degrees. The next step is to calculate the angles of N and P. And we're going to use supplementary angle theorem to calculate this. We know that when you have supplementary angles, they add up to make 180, which is a straight line. And we see that there's a straight line here divided by this line segment. So we have this actually line segment here, angle V and angle P. When we add those together, they should equal 180. Well, since we already know that angle V is 108, we can take 180 degrees minus 108, leaving angle P at 72 degrees. The same calculation can be made here, and angle N will be 72 degrees. So angle P and angle N is equal to 72 degrees. Well, if you get a ruler, you will find that these line segments, all of them, are exactly the same. Thus, in a pyramid, all the edges are going to be the same length, along, not counting the base edges, but along any of these triangles up to the top vertex. So these edges are the same, thus making anything within these triangles are all going to be isosceles triangles. So we know this is 72 degrees and this is 72 degrees, which add together to give us 144. And we know by this calculation, n minus 2 times 180, that the sum of these three sides, minus 2 times 180, there are 180 degrees in any triangle. So we've already used 144, and if we take that from 180, we have remaining 36 degrees for angle Q, M, I, F, and C. Now we haven't actually made the calculations, but since this is a pyramid, all these triangles are going to be exactly the same, so therefore these angles are going to be the same in each one, and these angles will be the same in each one, forming the pyramid. When you add this plus this plus this plus this, you have 36 degrees times 5, which is exactly 180 degrees, and you can see that this forms a semicircle. And it also forms a straight angle along the base right here. So we can take any of these nets and we can make calculations. We can also determine whether or not an angle is acute, reflex, obtuse, or straight. Any angle that is less than 90 degrees is an acute angle. Any angle that is exactly 90 degrees is a right angle. Any angle that is bigger than 90 degrees but less than a straight angle, or 180, is called an obtuse angle. A straight angle is exactly 180 degrees, and a reflex angle is any angle between 180 and 360 degrees. So this is how you use the 3D nets to make calculations based on different angle theorems.